So you're probably taking a look at this one and thinking, ah, hell no, I can't solve this one. But I'm gonna tell you, you can do it. You just have to do the same stuff, right? You just gotta use your Ohm's law. You gotta use your Kirchhoff's current law. And you gotta use your Kirchhoff's voltage law. All right, so there's a whole bunch of stuff here. So it's like, how do we even begin? Okay, so let's list out what we gotta find. So we have B2 question mark. We have B4 question mark. B5 question mark. And I1. And then I4. Okay. All right, so let's take note of what we have here, but I first want to just again, it's set up in the way that a conventional current goes, and you can solve it this way. But for our course, we're going to focus on electron flow. And we're going to have electron flowing from the negative end of the battery all the way through the circuit here. Okay. We have multiple elements here. We have a parallel over here, parallel part over here, but really it's not too bad. Okay, so I'm just going to reverse these around. All right, so let's analyze this step by step. So if we look at the beginning, we have 72.0 volts. So that's what we're starting at for voltage. We know that all of the voltage drops that we see here, right? We see a voltage drop here, right? We're going to see voltage drops here, a voltage drop here. We're going to have to eventually be at zero at this point, okay? So keep that in mind, right? We can't, create or destroy energy, right? So if we started with this energy, it's going to have to get used up over the loads that we have here, okay? So let's take a look. So we can let's actually focus on the voltage. Let's do our voltage first. Why not? Since it's coming first, then we can always do current later, okay? So if we have 72 here, so we have 72.0, we're using up volts over this this resistor here. So we used up 36 across this. So what are we left with over here, right? We're left with 36 at this point. So we got 36, these electrons are at that 36 volts and coming around here. And this kind of gives us a clue that on one of these paths, they use 20 volts. Okay, 20 volts was used up here. And since these are in parallel, right, we actually know that if this is actually going to use 20 volts as well, okay, because these are in parallel, like so. So if we had 36 up here, right, think of the water slide analogy, right? Think of people at, floor 36, right? And we're going to go down these water slides and we're going down 20 floors each, right? And we're going to be left at the 16th floor, right? So after we go down this one, right, those electrons have essentially taking 36 minus 20, so we'd be left at 16. You go down here, you're going to lose 20 there as well, so you're left at 16. So all the electrons down here are at 16 volts. And we know we have to be at zero by the time we get over here back to the battery, right? Then they get charged up again. They just keep going through the entire little merry-go-round here, okay? So we're at 16 here, and we know, again, we have another parallel circuit. So we have a voltage drop of 16 over here and a voltage drop of 16 over here. Let me fix those arrows here, okay? So think of voltage as those electrons, but they're brought up to a certain energy level. So there'd be a drop of 16 over here and a drop of 16 over here. And that means we're left with these electrons over here at zero, and then they go back through the battery, right? The battery brings them up to that higher energy level again, and then they just keep going through until this battery eventually runs out of its chemical potential energy. So to recap, right, 72, right, we minus 36, we end up with 36 left over here, and then if we're going down the parallel paths here, it's going to be 36 minus 20, then we're left with 16, so we know that our 20 here is the V2. Okay, that's good. And we're left with 16 here. Okay, and then as we go through these paths, that's going to use up the 16. And we got 16 volts here. And we got 16 volts here. And that's going to bring us to 0 volts over there. So just by using an idea, right, Kirchhoff's voltage law here, we're able to just analyze the circuit. There's really not many calculations that we're doing there. Just some simple subtraction and just knowing that all of that energy has to be used up by the time we get here, right? We can't create or destroy energy, okay? All right, getting into I1. So now current, this is gonna be your flow of electrons here. And we know when we have multiple paths here, right, current can split up. So kind of a key indicator would be looking at the junctions that we see here, right? So especially this junction, okay? Because we got current that's gonna move this way, and this is unknown right now. It's gonna go here, and we got some going down here, and we got some going down here, okay? And it looks like we got 2 and 4. So that means that the current that we had going into the junction has to equal the current leaving the junction. So that is Kirchhoff's current law. Okay, so if we have 2 and 4, that's essentially going down these paths. That means that that junction going into it, that would have been 6 amps of current. So after our electrons go down there, again, back to the water slide analogy, down the water slide, right? And this current is gonna add up over here as well. So the 2 and the 4 is gonna go back together, then we have 6 over here, okay? So now we're going down a couple more water slides, right? And we have, it looks like it tells us that we got 5 amps of current going down this way, okay? So obviously this has to be 1, right? Because 5 and 1 gives you 6, right? If we started with 6, we got 5 and 1 over here. So we got 4, I equals 4, that is gonna give us 1 amp. And that is essentially all we have to do here. Of course, this current's gonna join up over here. We got 1 and 5, that's gonna give us 6 by this point. And we know that current in this entire circuit here, right, it's not gonna exceed 6, right? So, because we started with this initial current, that's 6, we ended off with 6 here. So through this entire loop here, we didn't, create or destroy charge, right? Charge being those packets of electrons that come through, right? All right, so, and we could find more information here. I'm always a good advocate of finding as much information as possible, but the question itself just says stop here, so I think we'll do that. If we wanted to find what our resistances are, right, so we can essentially find our R1, right, we could find our R2 if we wanted, we could find our R3, we could find our R4, we could find our R5, so we can figure out how much resistance we'll see here. And even just by looking at this, we know, like, if we have more current going down this path here, chances are this is gonna have less resistance, right? It's gonna have less resistance there, okay? Matter of fact, why don't we figure it out? We got some time. Why don't we figure it out? Okay, so I'm gonna start with the first one here. So we got V1 equals I1 and then R1. Okay, we're gonna do this for all of them. It's kind of boring, but hopefully I can keep this under 15 minutes. Okay, so we want to find our R1 here. So we're gonna divide both sides by I1. Those cancel. We have R1 is equal to V1 over I1. So we have our V1. Okay, so we got that, and that is gonna go over, it's gonna go over our I1 here. Okay, so that's gonna be our amp value there. And it looks like we're ending off with, yeah, that's gonna give us our 6 ohms over here. Okay, 6 ohms. All right, so we got 36 over 6. That's gonna give us our 6 ohms. Let's do the rest. We got R2, and I'm not gonna rearrange this again because we know the formula is gonna be the same. We got our, what do we got here? We got our V1 over our oh my goodness, V2, excuse me, I should say that. What happens when I go in a little bit of a rush here. Here we go. So we got our R2, so we got our V2. Okay, so V2, we got our 20. Okay, so we got 20 here, because remember it's in, it's going to be in parallel, right? So we got 20 over the current, so it looks like we had 2 amps of the current go down here. Okay, so it looks like we're going to end off with our 10 ohms here for R2. Probably gonna run out of space here, but let's do R3. See if that validates, you know, how fun this water slide is compared to this one. So we got our R3 is gonna be, we got V3 over I3. Okay, so R3, that's gonna be your, again, 20 or 20.0, right? Doesn't really make a difference there. This is going to go over our current. We got 4 here. So we got our 4 amps, or 4.0, whatever you want to do there. And we have R3 is going to be, so we're looking at 5, right? So we got 20 divided by 4. That's going to give us our 5 ohms. And it checks out. It seems like there's less resistance down here. So that's why the majority of our current's going down this way. All right, so that totally checks out there. Okay, I feel like this marker is starting to kind of run out here, but this one's probably not much better, let's be honest. And let's do our R4. Okay, so we got our R4 here. R4 is gonna be, we got our V4 over our I4, okay? So we got that, so we got our V4, well, V4, we calculated that. We know that for certain. It is right here. We have our 16. Okay, we have our 16 volts here. And that's going to be over the I4. That's going to be 1 amp. So this is kind of looking like it has quite a bit of resistance here. So we have our 16 ohms here for the R4. And that does check out, right? Because look how much current decided to go down this path, right? There's a lot of resistance there, so most of it's going down this way. Okay, now we got our last one. Our last one here, hopefully gonna stay under 15 minutes. All right, so we got our R5, V5 over I5. And yeah, so we got our, it's gonna be, we got our 16 volts over our 5. And what are we looking at here? We're looking at, oh, I'm not gonna pull up the calculator for this, right? We're looking at 3 point something, right? Let's see. Okay, we got, okay, yeah, 3.2. That's what I figured, yeah. Okay, so our R5, yeah, R5 is gonna be that. So we got R5 is gonna be our 3.2, and that is ohms. Yeah, anyway, can't believe I pulled up the calculator for that last one, but that's all right. Got to make sure we put the right answers in here. So, yeah, you didn't have to find all those resistances, but it really does kind of help validate our laws that we used here, right? So when in doubt, just always, you know, use your Ohm's law, use your Kirchhoff's current law, use Kirchhoff's voltage law, and you can pretty much solve everything you want to know about a circuit here. Okay, hopefully that helped. And again, we'll stick with the theme here. Let's see if we matched our answers here for just be problem 6. So we're looking at 20 volts for V2, 16 for V4 and V5. Our current for I1 is 6, and for I4 is going to be 1. And it looks like that checks out real nicely here. Okay, perfect. Anyway, hope you have a good one. Hope this helps, and all the best when you're completing that problem on the front page. See ya.